Okay, Foundation of Pre-Cal 10, here we go. We got our third method of solving systems, and in this case, we are going to use substitution, a very, very helpful tool, but often not used as prolifically as it should. So let's look and see what that all means. So here we have two equations, 2x plus y equals 4, and then 3x plus 4y equals 1. Well, you could set this up for addition, but let's look at substitution. What we mean by that is we are going to substitute a statement with a variable with respect to another variable. So that might sound like, what did he just say? Well, let's isolate one of the two variables. So in this case, y is already positive, so let's get y alone. So I create this new equation, well, basically the same equation, just in slope-intercept form. Y equals 2x plus 4. So what that does is that gives me a statement of equality where I have y as a variable equal to a statement with respect to x. Y is exactly the same as negative 2x plus 4. So what that means is in any other scenario where you see a y, you can substitute in that equal statement. So I'm going to substitute in negative 2x plus 4. Now the brackets are incredibly important because you have to remember you are multiplying by all of that. So I have substituted this for the letter y because they are equal statements. You can do that. It is incredibly handy. So what do we do from here? Well, we do algebra. Water bomb, water bomb. So now 3x minus 8x plus 16 equals 1. That's negative 5x equals negative 15. I've just combined my x's and subtracted 16 from both sides. And then divide both sides by negative 5, x equals 3. And now super handy because you can sub it back into this equation because it's already written in terms of y. So now I can just solve for y relatively quickly. Don't have to do any crazy algebra, it's just arithmetic. So y equals negative 2. So I solve for 3 comma negative 2. And let's do our due diligence. Let's check our equations. So when x is 3, y is negative 2. Well, yep, 6 minus 2 is 4. And then when x is 3, y is negative 2, and that's 9 minus 8 is 1. So we're good to go. So we substituted a statement for a variable, and that statement is written in terms of the other variable. Very handy, very helpful. So let's look at another. Now in this case, here my x is basically coefficientless. There's a negative 1 in front of it, but I am going to want positive x. And you could do some algebraic manipulation, or you could just do your other algebra. I'm going to multiply this entire equation by negative 1. Because that's going to change this to positive x minus 8y equals 5. And I only do that because now I just have to add 8y to both sides. And once I've done that, I have an equation in terms of x this time. So I have x equals 8y plus 5. So what I can do is I can sub that in for this x here. So now I have 2 times 8y plus 5, the brackets are so important, minus 4y equals 7. From there, I will multiply in, multiply in. I now have 16y plus 10 minus 4y equals 7. So group your like terms, 12y, and then subtract 10 from both sides equals negative 3. Divide both sides by y, and y equals negative 3 over 12, which is equal to negative 1 over 4. Now at this point, you might be panicking. You're like, whoa, 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 that's a negative. I'm not comfortable. And not only is it a negative, it's a negative fraction. Nothing wrong with a fraction, okay? Fractions exist. They exist on a coordinate plane. You can cross through a fraction. There's no rule that says it has to cross at an integer. So be confident in your math. Double check, make sure if you're feeling like, why do I have a fraction? But be confident and then continue and let's see what happens. Because if we plug that in up here for y, we end up with x equals 8 times negative 1 over 4 plus 5. Remember that the 8 cancels with the 4, you're left with a 2. So x equals negative 2 plus 5, x equals 3. So we end up with the coordinate point 3 comma negative 1 over 4. Now, yes, that might seem like a weird answer, but it's only weird in a narrow scope of solutions. You need to be aware that there's an infinite number of potential solutions. So let's do our due diligence. 2 times 3 minus 4 over negative 1/4. Well, that means 6 plus, because negative times a negative, right? 6 plus 4, and 4 times a quarter is 1. So 6 plus 1 is 7. And now negative 3 plus 8 times negative a quarter means negative 3 plus negative 2. So again, we are fine with negative 5. So when in doubt, double check your solution. Let's look at another one. Now in this case here, my y is almost alone, but it's a negative. So again, I'm just going to multiply this whole equation by negative 1 first. Gives me negative 3x plus y, which was what I wanted, equals negative 5. And now I'll add 3x to both sides and end up with the equation y equals 3x minus 5. So I'm going to sub that y value in for here. I get negative 6x plus 2 times 3x minus 5 equals negative 10. Don't forget the brackets, remember? And then water bomb. Negative 6x plus 6x minus 10 equals negative 10. Well, those cancel, and you're left with negative 10 equals negative 10. If you add 10 to both sides, you get 0 equals 0. So we're comfortable with this. This means what? This means infinite solutions. If that had come out untrue, if it was an untrue statement, then we would have just had no solution. So when our lines are parallel, in this case, it means these are the exact same line. And if you look algebraically, they are the exact same line. What we've done is this line has been multiplied by negative 2, and that gives you that. So it is the same line, just written in a redundant fashion. So that is why we have infinite solutions. So those are our 3 methods: solve via substitution, solve via addition method, solve via graphing. Pick whichever one you're most comfortable with. I'm going to assume most people will like addition, but look at the given scenario. If you have an equation that starts off in slope-intercept form or in a form where it's x equals, use substitution. It's already set up for you. You don't have to do as much algebra. Okay, so enjoy, and next video is how do we solve these in word problems. Okay, see you next time.